Maths channel are now answering question number 10, part 2 from the October-November 2017 Pure Mathematics paper 1. This is from Cambridge 9709. This is paper 1 variant 3. And this question here is actually in my end of topic worksheet of differentiation because of part A based on part 1, but it's basically about integration. So I've saved it in a different as a different video so that I can save it under my integration playlist as well. So it says it is now given that the curve has a stationary point at -2, -3, and the gradient of the curve at x is not x equals 1 is 9. Find f of x. Okay, so this is what we have so far. We have the equation of the gradient function in terms of a and b, where a and b are positive constants. So now we need to find the actual function itself. So we need to find the values of a and b first, I guess, and then we need to integrate this to find f of x, and find the constant of integration to complete the question. So basically now they've given us some information about this, which is important. They've told us that there is a stationary point at -2, -3, which means that when x equals -2, the gradient is equal to 0. The gradient is equal to 0. So that's f dash of x is equal to 0 when x is -2. So from that we can deduce that f dash of -2 is going to give us 0. And they've told us that the gradient of the curve when x equals 1 is 9. So the gradient of the curve when x equals 1 is 9. So that means that when we put 1 inside the gradient function, what comes out is 9. So from this we can form a pair of equations in a and b, which will help us to then find what they are simultaneously. So I put -2 instead of x. I have a times -2 squared plus b times -2, and that's equal to 0. And when I put 1 in here, I'll have a times 1 squared plus b times 1 is equal to 9. So this leads us to the equation for a -2b is equal to 0. And this leads us to the equation a plus b is equal to 9. So I can actually take this equation number 1, call this equation number 2. I can take this equation, I can divide it by 2 to make it simpler. That gives me 2a. So this equation becomes 2a minus b, okay, is equal to 0. And if I add these two equations together, I'm left with 3a is equal to 9. That will eliminate the b. So a is equal to 3. And if a is equal to 3, then you got a plus b equals 9. So 3 plus b equals 9, which means b is equal to 9 minus 3, which is 6. Okay, so we end up with our gradient function f of x is going to be equal to, therefore, it's going to be a, which is 3 times x squared plus 6 times x. Okay, so that's our gradient function. Okay, now that's our gradient function f dash of x equals 3x squared plus 6x. Now we know that y, or f of x we could say, is when you integrate the gradient function with respect to x, you get the original function. Okay, so we also know that this curve passes through the point -2, 3, because that's a stationary point on the curve, right? So we know that definitely -2 and -3, okay, lies on the curve. It's definitely on the curve because it's a stationary point. So this point satisfies the equation of f of x. Okay, it lies on f of x. Okay, so we can use those, that piece of information to find the actual function in its actual form. So what I'm going to do here is I'm going to say let y equals f of x. Okay, so I'll say y equals the integral of 3x squared plus 6x with respect to x. Okay, and I'm going to do this in a kind of a bit of a strange way for some of you. Okay, I'm going to use definite integrals. Okay, so what I'm going to do is I'll say, okay, I want to find what y is. Okay, and I know a point when y is -3. I want to find out what y is in terms of x. I'll do this. I'll put y here and I'll put x here because this is dx. So I want to find what y is in terms of x, and I know that when y is -3, x is -2. Now this will help me to find the constant of integration directly. So this will give me y minus, be careful here, -3. Okay, because this is like after you've integrated, you put the values in. So when you integrate f dash of x, you get basically f of x, which is like y. So you put y in here and you put -3. Take away from that what you get when you put -3 in there, equals, now this is going to be integrated. So I'm going to have 3x cubed over 3. Okay, when you integrate that, you add 1 to the power, divide by the new power, so that will give you x cubed. And 6x squared over 2, 6x squared over 2, that's going to give me plus 3x squared. So this will be 3x cubed over 3, 3's cancel, 6x squared over 2, that leaves you 3, so you're left with x cubed plus 3x squared, and then I've got my limits of x and -2, so I'm going to have here y plus 3 is equal to, I'm going to have x cubed plus 3x squared, that's what I get when I put x in here, minus, and don't forget to bracket here, -2 cubed plus 3 times -2 squared. Okay, so this gives you x cubed plus 3x squared, and you got y plus 3 here, and that's going to give you minus, and that's going to give you -8 plus 12, because that's 3 times 4, because -2 squared is 4. So you're left with y plus 3 equals x cubed plus 3x squared, and that's going to be minus 4. 12 minus 8 is 4. So y is going to be x cubed plus 3x squared minus 7. So that is our equation for f of x. We say f of x is equal to x cubed plus 3x squared minus 7. Right? That's a nice way of doing it without having to put plus c. And of course, we can do it in the normal way, which I'll do over here. I'll just make a bit of space for it. Okay, the normal way would be where you basically just say that, and most of you might probably prefer to do it this way that I'm going to do now. I just like to do this because it prepares you for things like differential equations later on, ways to make life easier for yourself then. But we could say f of x is equal to the integral of 3x squared plus 6x, and we can treat it like an indefinite integral. So we say, okay, f of x is equal to 3x cubed over 3, which is x cubed, plus 6x squared over 2, which is 3x, plus c. And we know that it goes through the point -2, -3. So we can say when y is -3, x is -2. That should be 3x squared, sorry. Okay, plus c. Okay, that's x cubed plus 3x squared plus c. So you have -3 equals -8 plus 12 plus c. So you have -3 is equal to 4 plus c. Therefore, c is equal to -7. So now we can put the values in here. So we say f of x is equal to x cubed plus 3x squared minus 7. Okay, so whichever way you prefer, that's fine. I just thought I'd give you an alternative way of doing things. So that answers this question. Question number 10 from the paper from October, November 2017. So if you would like to find other questions from this paper, you can go to the link at the top right of the screen at the end of the video. If you'd like to find the other part of this question, part 1, you'll find it there. And also you'll find it in the end of topic worksheet number 12, which is linked at the bottom right of the screen. At the end of the video, you can watch other questions dealing with differentiation from my P1 collection in this screen here. And you can subscribe to my channel by clicking on this link at the top. Thank you for watching, and see you soon.